In today's session, we will solve a problem in Cyclic Redundancy Check CRC. As usual, let's start the session with the outcomes. Upon the completion of this session, the learner will be able to generate the CRC code and determine the message to be transmitted. Let's dive into the question. The question is, the message 11001001 is to be transmitted using CRC polynomial x cube plus 1 to protect it from errors. The message that should be transmitted is, and this was the question that was asked in GATE Computer Science in the year 2007, and options are given. Option A 1100100100, option B 1100100111, option C 11001010, and option D 1100100111. In order to solve this problem, we need a strong understanding about the generation of CRC, because the message that should be transmitted is this original message that is appended with the CRC code. Let's see how to generate the CRC code. We have basically 5 steps for solving this problem. Step number 1, finding the length of the divisor L. And step number 2, after we find the length, we will be appending L-1 bits to the original message. Suppose if the length of the divisor is 5, we will be appending 4 bits to the original message, and then we will perform the binary division operation. To perform the binary division operation, we need to know the exclusive OR operation. So for same input, we will be getting 0 as the output. For different inputs, we will be getting 1 as the output. Then after we complete the binary division operation, whatever we get as the remainder, that is the CRC code. And the message to be transmitted is the original message that is appended with the CRC code. So please note, the CRC code must be of L-1 bits. In step number 2, we appended L-1 bits to the original message before we carry out the binary division operation. So L-1 bit should be the CRC code. Let's solve the problem. So in the given question, the length of the divisor is 4. How we got 4? Because the divisor is given in the polynomial expression. When we convert this polynomial expression like this, x cube means 1x cube, and there is no x square and x, so I am putting 0x square and 0x power 1, and we have a constant here, so I am putting this constant. Now when we take 1, 0, 0, 1, that is the divisor. So we know the divisor is 1001, and the length of the divisor is 1, 2, 3, 4 bits. So the length of the divisor is 4. And step number 2, we will be appending 4 minus 1 bits to the original message. That is, 3 bits are going to be appended before performing the binary division operation. Once the binary division operation is carried out, we will be obviously getting the remainder. So the remainder is the CRC. And then the last step is, the message that should be transmitted is, we have the original message that is given in the question, and whatever we get as the CRC, that is the remainder, and that is appended with the original message. And we are required to make a note of one thing very important. The CRC code must be of L-1 bits. That is, here L-1 is 4 minus 1. So the CRC code will be of 3 bits because we have appended only 3 bits to the original message. Let's solve the problem. And we know this is the divisor. Actually, the divisor is given in the polynomial expression. And we know how to convert this polynomial expression into binary. And this is the original message that is given. If you recollect step number 1, we are required to append zeros. How many zeros will be appending? The length minus 1 bits. Here the length is 4. So we are intended to append 3 zeros. Now let's start the division process as usual. 1001 is the divisor. 1 times it is 1001. We'll perform the exclusive OR operation now, and the result will be 101. As per the division rule, we will not be taking this bit into account. When we perform exclusive OR between 1, 0, we will get 1, 0, 0, it is 0, and 0, 1, it is 1. And then we'll be obviously bringing the next bit. Then 1001, that is this divisor, 1 times it is 1001, and we'll be getting the intermediate result as 0, 0 is 0, 1, 0 is 1, and 1, 1 is 0. And we'll be omitting this. So the next bit obviously comes into picture. When we try to divide, it's starting with 0, but here it is starting with 1. So we can't perform the division right now. So what we are going to do, we are going to add a 0 here and bring the next bit. So when we add a 0 and when we bring the next bit, we will be having 1 0 0 0. So 1 0 0 1 1 times it is 1 0 0 1. When we perform the division, we'll be getting 1 1 is 0 0 0 1. Yes, the next bit comes automatically. So we'll be getting 0 0 1 1 because we'll be omitting this bit. Now when we try to divide, it's starting with 0 and the next bit is also starting with 0. So what we are required to do? We are required to bring the next two bits. So what I am doing here is, I am adding two zeros in the quotient so as to bring these two bits. Just observe, I am adding for the first 0 and I'll be bringing this bit. Again I am adding the next 0 and I am bringing the next bit. So we will be getting 1 1 0 0. Now this is ready for division. So 1 0 0 1 1 times is 1 0 0 1. When we perform the division, this becomes 0 and this is 1 0 and 1. And then obviously the next bit will come into picture, and 1 0 0 1 1 times is 1 0 0 1. When we carry out the exclusive OR operation, we'll be getting 0 0 1 1. Let's check it out. 0 0 1 1. Yes, we got the remainder. Is the CRC 0 0 1 1? No, it is 0 1 1. Please recollect the important point that I have told you. It has to be L minus 1 bits because how many zeros we have appended? 3 zeros. So 3 bits should be the CRC. So the CRC is 0 1 1. So far we are done with calculating the CRC. That is, we have generated the CRC. Now we are required to find the message to be transmitted. We know the message to be transmitted is the original message appended with CRC. Here this plus denotes is appending. The original message that is given in the question is 1 1 0 0 1 0 0 1 and then just append the CRC. We have calculated the CRC, that is 0 1 1. So we know the message to be transmitted is 1 1 0 0 1 0 0 1 0 1 1. Let's revisit the question. In the question, we are required to find out the message that should be transmitted, and we know the answer is option B, which is 1 1 0 0 1 0 0 1 0 1 1. In case if you don't find time and if you want to scrutinize these options, I'll give you a shortcut. See, if you observe option C, this C is obviously invalid. Why? Because when we are required to find the message to be transmitted in CRC, we'll be getting the original message that is appended with CRC. So obviously this will be in the starting place of the options. If you observe, option A is having that original message, option B is having, and option C is also having. So we can blindly ignore option C and we can try doing with option A, B or D. Finding the message to be transmitted in CRC will be easy in most of the cases because the original message, in this case that 1 1 0 0 1 0 0 1 will be appearing in the options. But unfortunately we can't just like that choose the correct answer because there are options A, B and D that are starting with the original message that is given in the question. Sometimes it may help us. And what we have learnt in today's session, we know how to generate the CRC code and we also know to determine the message to be transmitted. I hope you liked the video and thank you for watching.